to all. Welcome to Sigma e-learning Smart Way to Excellence. The topic we'll discuss today is the probability. What is probability? Probability is possibility or chance of happening of an event. Simply, the probability is possibility or chance of happening of an event. That is probability. In our practical life also, we have several times we have gone through the concept of probability. Let's say, for example, several times in newspaper we have seen there is a 30% chance of raining today. In IPL also, the cricket experts predict winning team of IPL. Sometimes we can say it's impossible to be happen. So all these words are regarding the probability. In this chapter, we learned about the mathematical concept of probability. So what mathematics talk about the probability? How the probability of event can be calculated mathematically. So in this chapter, we'll discuss all these things. How to interpret the probability mathematically means in terms of values. Let's say, for example, if an event must be happen, then its probability will be 1. If an event impossible to be happen, then its probability will be 0. See, the probability 0 means this is impossible to happen, or there is 0% of possibility to be happen. And also, if the probability is 1, there is 100% chance of happening. So in this manner, mathematically, we will discuss various concepts of probability in this chapter. See the point number 2. The probability is always in between 0 and 1, or in between 0% and 100%. So what is experiment? Simply, experiment is a process that lead to one or more outcomes. The sample space. What is sample space? The sample space is a set of possible outcomes of experiment. A set of possible outcomes of an experiment. Let's say, for example, when I tossed a coin, two possibilities to be happen. The first thing is it can be head. The second thing is it can be tail, which means I have two possibilities. It can be head or it can be tails. So I have two possibilities. So these are all the possibilities I have in this experiment, which means that in an experiment of tossing a coin, I have total two possibilities. The first one is it can be head or it can be tail. What is event? Simply, the event is a specific outcome or required set of outcomes from the sample space. This is all about experiment, sample space and event. In the example 1, experiment is tossing two coins simultaneously, which means I have two coins in my both hands. I am tossing these two coins at a time. So I am tossing two coins at a time. Then I have four possibilities of outcome. First coin can be head. The second coin also can be head. So this is one possibility. The first coin can be tail. The second coin also tail. So this is another possibility. The first coin can be head. The second coin can be tail. This is another possibility. The first coin can be tail, head, head, tail, tail, head, tail, tail, head. These are all possible outcomes in this experiment. In previous slide, we had learned the sample space is all the possible outcomes. I can call it as a sample space. Then coming to the event. We have to find the event in this experiment with regard to event for at least one head. See, we have to find the event for at least one head. See, these are all possible outcomes of my experiment. Head, head, tail, tail, head, tail, tail, head. But we have to find the event for at least one head. We have to search in this sample space where is at least one head. See here, the first possibility, we have one head, 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 which means there is at least one head. So I am considering this. So I write here head and head. Why? Because I have at least one head. Then come to the second possibility. The second possibility is tail, tail. Is there any at least one head in this possibility? No. So I won't take this tail, tail. Why? Because I need to have at least one head. So I won't take this. Why? Because I need to have at least one head. So I won't take this. Then come to the third possibility. Head, tail. I have one head here. So I'll take it. So I'm writing here. So coming to the fourth possibility. There is one tail, one head. So in fourth possibility also I have at least one head. So I'm considering this. So which means that in the event of at least one head. I have 4 possibilities which have at least one head. See here, observe carefully the sample space. I have at least one head here. I have at least one head here. I have at least one head here. So I am taking all these 3 events from the sample space here. Head, 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 tail, tail, head. These are events in the given experiment. Why? Because these are the possibilities, or these are possibilities which satisfied my condition. The condition is at least one head. So I am choosing head, 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 tail, tail, head. Why? Because they have at least one head. So in this experiment, my event is 3, the sample space is 4. So in this way, we have to calculate the sample space and event of the experiment. Simply, the sample space is all the possible outcomes. The event is outcomes which satisfy our condition. What is condition here? We have to get at least one head. So I got this 3 possibilities. Why? Because they have at least one head. So in this manner, we have to calculate sample space event from the given experiment. If n coins tossed, then sample space will become 2 power n. In this experiment, I am tossing 2 coins. So I am substituting in the n place 2. 2, which means 2 square, which is nothing but 4. So I am tossing 2 coins. That's why my sample space will be 4. If I toss 3 coins at a time, my sample space will become 2 cubed. If I toss 4 coins at a time, then my sample space will become 2 power 4. In this manner, we have to use this formula to find the sample space of experiment with regard to the coins. Coming to the example 2, here the experiment is tossing a dice. We know that a dice is a cube which has 6 faces. Certain numbers have been right on the each face. We have 6 faces. Each face has some numbers on them. Here the sample space is 1, 2, 3, 4, 5, 6. Why I am calculating 1, 2, 3, 4, 5, 6? Simply the sample space is all the possible outcomes. If I tossed a dice, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6 also. These are all possibilities I have when I tossed a dice. So I am writing 1, 2, 3, 4, 5, 6 is my sample space. Is nothing but my sample space is 6. My sample space equal to 6. Then coming to the event. What is event? Event means the possibilities which satisfy our condition. What is condition here? The event of happening for getting more than a 3. The condition is here getting number more than 3. What will be the event for getting number more than 3? See here, these are all possibilities I have. How many possibilities are more than 5? Let's say 4 is more than 3. 5 is more than 3. 6 also more than 3. So I am considering 4, 5, 6. See here, I am considering 4, 5, 6 possibilities. Why? Because these 4, 5, 6 numbers are more than 3. So I am considering 4, 5, 6 from the sample space. So my event will be 4, 5, 6 equal to 3. In this experiment, my sample space is 6. My event is 3. Okay. In this manner, based on the experiment, we have to find out the sample space event. See the example 3. Here the experiment is tossing 2 dice simultaneously, which means that I have 2 dice, one dice in my left hand, the second dice in right hand. I am tossing 2 dice at a time. When 2 dice fall on the land, I have 36 possibilities of happening. Let's say, for example, first dice can be 1, second dice also can be 1. First dice can be 1, the second dice can be 2. The first dice can be 1, the second dice can be 3. First dice can be 1, the second dice can be 4. Can be 1, the second dice can be 5. First dice can be 1, the second dice can be 6. In this manner, we have 36 possibilities of happening. So I can say that these 36 possibilities are all the possibilities I have in this experiment. So I am writing all the 36 possibilities. See, These are all the 36 possibilities I have in this experiment. So all these possibilities means that is the sample space. In this experiment, sample space is 36. Then coming to the event. What is event? The event is the possibilities which satisfied our condition. What is condition here? Event of happening for getting sum more than 10. The condition is the sum is more than 10. Just observe 36 possibilities here. Which of the following has sum is more than 10? See here. So what is condition I have? Event for happening for getting sum more than 10. So that's the condition. See here. In this total possible 36 outcomes, I have to find out which possible outcome have the sum is more than 10. See here. 5, 6 is 11. 6, 5 is 11. See, 5, 6, 6, 6, 6, 5. These three possibilities, in these three possibilities, the sum will become more than 10. Let's say 5 plus 6, 11. So it's more than 10. 6 plus 6, 12. So it's more than 10. 6 plus 5, it's 11. It's more than 10. So I have three possibilities. Simply, from the 36 possibilities, I have considered these three possibilities. Why? Because these three possibilities satisfying my condition. The condition is the sum is more than 10. So here my event is 3. So in this manner, we have to find out the sample space and event. Let's note a formula here. If n dice tossed, are tossed, then the sample space will become 6 power n. In this experiment, I am tossing 2 dice, so the n will become 2. So the sample space will become 6 square. 6 square is nothing but 36. So my sample space will become 36. If I toss 3 dice at a time, then my sample space will become 6 cube. When I toss 4 dice at a time, then my sample space will become 6 power 4. So this is all about the finding the sample space and event from the given experiment. What is the probability of event E? If event E is happening, what will be the happening of an event E? The probability of E is nothing but P of E equal to number of possible or favorable outcomes by number of all possible outcomes. Number of all possible outcomes means is nothing but a sample space. The number of favorable outcome means is nothing but event. See here, in the given experiment, we have sample space is 36. So these are all possible outcomes. The favorable outcome is nothing but event E. The favorable outcome is 3. See here, 5, 6, 6, 6, 6, 5. All total 3 events we have. In this manner, we have to substitute the value of sample space and value of event in the probability formula. The probability formula is the favorable outcome by all the possible outcomes, which is equal to event by sample space. We have to substitute the sample space, which is nothing but all possible outcomes, and the number of favorable outcome, which is nothing but event. When we substitute in this formula, we will get a value. That value will become the probability of that particular problem or that particular experiment. See example number 3, point number 5. Find the probability of getting a head when a coin is tossed once. Also, find the probability of getting a tail. In the problem, the experiment is tossing a coin. We know that coin has head and tail. Every coin has head and tail. So the experiment is tossing a coin. In this experiment, we have to find the sample space and event. Later, we have to find the probability. See, first we will find the sample space. Simply, what is sample space? Sample space is all the possibilities. In this experiment, I am tossing a coin. I have the first possibility, it can be head. The second possibility, it can be tail. So I have total 2 possibilities. So my sample space will become 2. Then coming to the event. In this problem, he asked the probability of getting a head and the probability of getting a tail. So these are 2 conditions he asked. We have to find out the possibilities which satisfied our condition from the sample space. Here, see here the sample space is head and tail, which is nothing but the sample space equal to 2. We have to find the condition which satisfied head and another condition which satisfied tail. We have to find the event of H or event of tail. These two possibilities are maximum possibilities. So the maximum possibilities I have two. So it can be head or it can be tail. So my sample space will be 2. We have to extract the event of H from the sample space. See, the sample space is equal to 2. Head and tail is my sample space. We have to find the event of H. So the condition is I have to find the possibility H. I have the possibility H. I have the possibility H here. So how many possibilities of H? I have only one possibility. So my event of H equal to 1. Then coming to the, what is event of tail? What is the probability of getting a head? Probability of getting a head is the event of head by sample space. What is the event of head here? So it's 1. So I am substituting 1 here. Why? Because the event of head is 1 by all the possible outcome is 2. So the probability of getting head is 1 by 2. Then coming to the probability of getting tail, which is nothing but the event of tail by the sample space. What is the event of tail here? 1. And the sample space is 2. By substituting, I will get the 1 by 2. So overall, the probability of getting head is 1 by 2 and the probability of getting tail also 1 by 2. Note a formula here. The sum of probabilities of all the elementary events of an experiment equal to 1. In any experiment, the sum of the elementary probabilities always equal to the 1. See the example number 3, point number 6. A game consists of tossing 3 coins and noting an outcome of each time. A game consists of tossing 3 coins and noting down the outcome of each time. If getting the same result in 3 coins is considered as a success, find the probability of winning and losing. The second problem is find the probability of getting at least one head. So these are two problems he asked in this problem. The experiment is tossing 3 coins at a time. In that game, the experiment is tossing 3 coins and noting the result, which means that when tossing the coins, there can be some results. It can be head, one coin can be head, one coin can be tail, and another coin can be head or another coin can be tail. In this manner, their players are noting that outcomes, whether it is head or tail or head and tail or tail and head. In this manner, they are noting the result after tossing each time of 3 coins. So that is the experiment. If getting the same result in 3 coins considered as a success, which means that when we toss up 3 coins, if 3 coins get the result of tail, 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 then it is the success. Or if 3 coins got head, 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 this is also considered as a success, which means that these 3 coins have to show the same result. From this experiment, we have to find the probability of winning or losing. So we have to find the probability of winning or the losing. Then the probability of getting at least one head. In any problem, we have to find the sample space and then event. Later, we have to substitute the sample space and event in the formula of the probability. What is sample space here? In the previous slide, I have explained the formula for the sample space when we tossed a coin. Here in this experiment, we are tossing 3 coins. So my sample space will become 2 cube, 2 power 3. Why? Because I am tossing 3 coins. So my sample space will become 2 cube is nothing but 2 power 3 equal to 8. So my sample space will become 8, which means when I toss 3 coins, I will get 8 outcomes or I will get 8 possibilities. Or 8 possibilities are head, head, head. Means the first coin will get head, the second coin will get head, that third coin also will get head. This is one possibility. The second possibility is the first coin will be tail, the second coin also be tail, the third coin also be tail. This is another possibility. In this manner, total 8 possibilities I have. See, in the third outcome, first coin can be tail, the second coin can be head, the third coin can be head. Another possibility, the first coin can be head, the second coin can be tail, third coin can be tail. So in this manner, we have 8 outcomes, is nothing but all the possible outcomes. I can say this all the possible outcomes as a sample space. So my sample space is nothing but 8. 1, 2, 3, 4, 5, 6, 7, 8. So my sample space is 8. Okay. From the problem or from the experiment, I have find out the sample space. Now I have to find out the event. What is event? Simply the event is the outcomes which satisfy the condition. Now we have to find the event. What is event? Simply the event is the possible outcomes which satisfies our condition. So that is the event. Here the condition is getting the same result in 3 coins. That is my condition. I have to find out the possibilities which satisfy my condition from the sample space. This is the sample space. I am finding the possibilities which satisfy my condition. What is condition? The same result in 3 coins. That is my condition. Let's checking this condition. See, head, 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 which means all 3 coins have same result. So, which is satisfied my condition. So, I am taking head, head, head as my event. Then coming to the second possibility, tail, tail, tail. This is also giving the same result in 3 coins. So, this is also satisfying my condition. So, I am considering tail, tail, tail here. Check the third possibility. Tail, head, head. Is it satisfied my condition? No. That's why I am not taking this outcome as my event. Why? Because this is not satisfied my condition. So, I am not taking this. See here. Is it giving the same result? So, I won't take this. Is it giving the same result? No. So, I won't take this. Is it giving the same result in 3 coins? No. So, I won't take it. Is it giving the same result in 3 coins? No. So, I won't take it. Is this giving the same result in 3 coins? Same result in 3 coins? No. So, I won't take it. So, only possibilities I have here, head, 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 tail, tail, tail. These 2 outcomes only satisfying my condition of event. So, I am considering these 2 outcomes as my event. See here, I am considering these 2 outcomes from the sample space in event. So, this is one event, this is the second event. So, total events in my experiment is 2. Now, I got the sample space equal to 8, the event equal to 2. Sample space is nothing but all the possible outcomes. Event is nothing but the favorable outcome. The favorable outcome is which satisfies our condition. Our condition is the same result will be occurred in 3 coins. So, head, 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 tail, tail, tail. These 2 possibilities satisfied my condition. So, I got the event as a 2. Now, I am just substituting the sample space and event in the formula of probability. So, my favorable outcome is or nothing but event is 2 by the total possible outcome is nothing but sample space is 8. So, it is became 2 by 8, which is nothing but 1 by 4. So, the probability of winning is 1 by 4. We have to find the probability of losing. So, from the probability of winning, I will get the probability of losing simply by using the formula. See, let's say this is the probability of winning, this is the probability of losing. I am rewriting the same formula, P of E dash plus always probability of winning, probability of losing always equal to 1. You just remember this formula. This is the very important formula in the probability concept. The probability of losing equal to 1 minus probability of winning. We know that probability of winning is 1 by 4. So, 1 minus 1 by 4, it will become 3 by 4. This is the probability of losing. Here, the probability of winning is 1 by 4. The probability of losing is 3 by 4. The first part of the problem has been completed. We got the probability of winning and the probability of losing. Then we have to find the second part of the problem. What is the probability of getting at least one head? This is the sample space. So, sample space is same for first part of question and second part of the question. We have to find the event of possibilities which satisfy the second condition in the second part of the problem. We know that from the experiment we got the sample space. We have already discussed. So these are all possible outcomes. 8. So I got 8 possible outcomes from the experiment. So what is event for me? Which means I have to find the condition to be satisfied. What is the condition here? Getting at least one head. Event or favorable outcome of getting at least one head. Getting at least one head is my condition. I have to search in the sample space which outcome is satisfying my condition. My condition is getting at least one head. See here, head, head, head. It has at least one head. Yes, so I'm taking head, head, head. Head, head, head. Then come to at least one head. It has to get at least one head. See here, tail, tail, tail. In this, is there any at least one head? No. So I won't take this. Observe this. Is there any at least one head? Two heads. So I can consider. Is there at least one head? Yes, I consider it. Is there at least one head? Yes, so I will consider it. Is there at least one head? So I will consider it. Yes, I will consider it. Is there at least one head? Yes, I will consider it. Is there at least one head? Yes, I will consider it. Observe a pattern here. In all the 8 possible outcomes, we have 7 possible outcomes which satisfied our condition. Which means that except this, all 7 outcomes satisfied my condition. Why this is not satisfied my condition means, so this outcome doesn't have at least one head. So this is not satisfied my condition. So I am not considering this. Except this, all 7 outcomes satisfying my condition. So I am considered 7 outcomes from the sample space. That is nothing but my event is 7, which means from the sample space 7 outcomes satisfying my condition. From the sample space, these 7 outcomes satisfying my condition. So my favorable outcome will become 7. Now we got the sample space as well as event. Simply we have to substitute in the probability formula. Simply the probability of getting at least one head is equal to event by sample space or favorable outcome by sample space. My event is 7, my sample space is 8. So the probability of getting at least one head is 7 by 8. So in this manner, we have to solve any problem in the probability concept. You just remember, in any concept of probability or in any problem of probability, first of all, we have to find the sample space or all the possible outcomes. This is the first step. The second step is we have to find the event. Event is nothing but the possible outcomes which satisfy our condition. We have to take this possible outcomes from the sample space only. We are not creating any special events. I am just taking from the sample space which are satisfying my condition. I am picking from the sample space and I am placing them in my event. So in this problem, from this sample space, I picked 7 items from the sample space and placed in my event. So this is the second step. The third step is simply we have to substitute the sample space and event in the probability formula. By simplifying, we will get the probability. A box contains 3 blue balls, 2 white balls, 4 red balls. If a ball drawn randomly from the box, what is the probability of getting white ball, the probability of getting blue ball, the probability of getting red ball? I have a box. In that box, I have 3 blue balls, 2 white balls, 4 red balls. Total, I have 9 balls. My friend randomly means he doesn't see the color of the ball. He randomly picked a ball. After picking, then what is the probability of getting a white ball? What is the probability of getting a blue ball? What is the probability of getting a red ball? In this example also, first of all, we have to find the sample space, later event. What is sample space here? Simply, the sample space is all the possible outcomes. When I have a 9 balls in my bag, A person pick 9 times. Yes or no? When I have 9 balls in my bag, any person each time one ball, if he pick each time one ball only, then he has the possibility of 9 times. If a person pick a ball from the bag, he has the possibility of 9 times. Why? Because 9 balls are there. So he has total possibilities to pick from that bag is 9. My sample space or nothing but the possible outcome or total possible outcomes will be 9. Why it is 9? I have 9 balls in my bag. If a person pick one ball at a time from the bag, he can pick 9 times. Why? Because each time he is picking only one ball. So he can pick 9 times 9 balls from that bag. So that is the total possibilities I have. The total possibility is 9, which is nothing but sample space. Got the sample space. Then we have to find the event of white ball, event of blue ball, event of red ball. Why? Because he asked 3 problems. What is the probability of white ball? What is the probability of getting blue ball? What is the probability of getting red ball? So I have 3 problems. So I have 3 conditions to be satisfied. So my event of white ball will begin 2. Why? Because I have 2 white balls in that bag. The event of blue ball will become 3. Why? Because I have 3 blue balls in that bag. The event of red ball will become 4. Why? Because I have 4 red balls in that bag. So in this manner, we find the event. Then coming to the probability. What is the probability of getting white ball? Simply, the probability of getting a white ball equal to the event of white ball by the sample space. The event of white ball will become 2. The sample space is 9. So the probability of getting white ball is 2 by 9. Then coming to the probability of getting blue ball. The event of blue ball is 3 and the sample space is 9. So which is 3 by 9. So that is the probability of getting blue ball. Then coming to the probability of red ball. The event of red ball is 4. The sample space is 9. So the probability is nothing but event by sample space. So which is equal to 4 by 9. So in this manner, we find the probability of white ball, probability of blue ball, probability of red ball. See, probability of white plus probability of blue plus probability of red equal to 1. White is equal to 1. We have a formula that in an experiment, probability of all the elementary events will become equal to 1. See here, probability of white, probability of blue, probability of red. All 3 are elementary events or probabilities of elementary events. So by summing all three probabilities, I'll get 1 as per the formula. So see the example number 5. A missing helicopter is reported to have crashed somewhere in the rectangular region shown in the figure. What is the probability that it will crash inside the lake which is shown in the figure? See, this is the rectangular space. This is the rectangular space. A helicopter going through this region. A helicopter is going through this rectangular region. There is a possibility that that helicopter will be crashed. So we have to find the probability of crashing in that lake. So that's the problem. Simply, the problem is there is a rectangular space. In that rectangular space, there is a square shaped lake. There is a possibility, there is a information that that particular helicopter will be crashed in this rectangular zone, this entire zone. In this zone, anywhere helicopter can be crashed as per the information. But we have to find the probability of crashing in the lake. We have to find the probability of crashing in that lake by the given data. What is sample space here? Sample space is nothing but all the possible outcomes. What is the possibility here? From the data given in the problem, the possibility is the helicopter can be crashed in the rectangular zone. This is all the possibility. So I have to find the total area of this rectangle. So I have 9 meters length and 4.5 meters of width. So my area of rectangle is the length into breadth, which is equal to 4.5 into 9, which is 40.5 kilometers square. So the area of this entire zone is 40.5 kilometers square. So this entire area will become the sample space for me. Why I am considering this entire zone as a sample space? Simply the sample space is the possibility from the given data. So I have the information that helicopter can be crashed anywhere in this rectangular zone. So this is the maximum possibility where a helicopter can be crashed. So I am considering this entire area as the maximum possibility. So that is 40.5 kilometers square. Okay, that's my sample space. Now I got the sample space. From this data, I have to get the event. Event is nothing but which satisfy my condition. The condition is the possibility of crashing a helicopter in that particular lake. See, this is the area of the lake. I have 3 kilometer length lake and 2.5 kilometer width of lake. So I have to find the area. Simply the area of lake will be 3 into 2.5, which is nothing but 7.5 kilometer square. See, the area of the large rectangle will become my sample space. The area of small rectangle will become my event. Okay. By substituting, the probability of helicopter can be crashed inside the lake is nothing but the favorable outcome by total possible outcomes. I will get 7.5 by 40.5, which is nothing but 5 by 27. 5 by 27 is the probability of helicopter crashing in the lake. See the example number C. 2 dice, one blue dice and one other one is grey dice are thrown at the same time. Write down all the possible outcomes. What is the probability that the sum of two numbers appearing on the top of the dice is 8 and 13 and less than or equal to 12? See, the experiment is here. 2 dice. I have 2 dice in my both hands. I have grey dice on one hand. I have blue dice on another hand. I am tossed all the 2 dice. I got some result. Let's say, for example, the first dice I got 1. The second dice also I got 1. First dice I got 1. Second dice I got 2. First dice I got 1. The second dice I got 3. First dice I got 1. The second dice I got 4. First dice I got 1. The second dice I got 3. In this manner, we have 36 possible outcomes, which is already discussed in previous slides. What will be the probability of getting the sum is 8? What will be the probability of getting the sum is 13? What will the probability of getting sum is less than or equal to 12? So, he is asking 3 questions in this example problem. What is the experiment? I have 2 dice in my both hands. I am tossing these 2 dice. I will get different results. The possible results will be all this. So these are 36 possible outcomes I can get by throwing 2 dice. These are 36 results I will get. Why 36 results I will get? In previous slides, I have explained a formula. If 2 dice thrown, our sample space will become 6 square. If 3 dice are thrown, the sample space will become 6 cube. So we got the sample space. We have to get the event or the favorable outcome. So in the first part of the problem, we have to find the probability of getting sum of two numbers is 8. Simply, there is a condition that the sum of the two numbers must be equal to 8. That is the condition, which means that from all the possible outcomes, we have to find the possibilities in which the sum is 8. See here, from the sample says, I am considering this outcomes 2, 6. Why? Because 2 plus 6 equal to 8. So, I am considering 2, 6. Second thing, I am considering 3, 5. Why? Because 3 plus 5 equal to 8. So, I am taking this. Come to 4 plus 4 equal to 8. So, I am taking this. 5 plus 3 equal to 8. So, I am taking this. 6 plus 2 also equal to 8. I am taking this. So, these 5 outcomes satisfying my condition. These 5 outcomes satisfying my condition. So I am taking or I am considering these 5 outcomes as my event. So my event will become 5. I know the sample space as well as I know the event. By substituting in the probability of sum of 8 equal to the favorable outcome by all the possible outcome. The probability of getting sum as 8 is 5 by 36. Then come to the second problem. Probability of getting sum of two numbers is 13. See here, observe all the possible outcomes. Is there any possible outcome which the sum is 13? Observe carefully. Is there any possible outcome in which the sum is 13? Nothing. There is no outcome in the sample space which is equal to 13. So my event will become 0. Why? Because no result in the sample space satisfying my condition. So my event is 0 here. So my event is 0 and my sample space is 36, which will become 0 by 36. So which is nothing but 0. So the probability of getting sum of two numbers 13 equal to 0. Why? Because I don't have any event of which results the sum is 13. So this is the 0 probability, which means this is impossible. So problem 2 is clear. Then come to the problem 3. Condition to be satisfied is the sum will be less than or equal to 12. We have to check each possible outcome which is less than or equal to 12. That sum must be less than or equal to 12. See, observe. These are all the possible outcomes. In all the possible outcomes, sum is always less than 12. See here, 1 6 less than 1 plus 6 less than 12, 1 plus 5 less than. We have to observe a thing. All these outcomes are less than 12, which means the sum of this all the outcomes less than 12, which means my event is 36. Why? Because all the possible outcomes are satisfy my conditions. I have total 36 possible outcomes or nothing but sample space. All these 36 items satisfy my condition. So my event will become 36. In this case, my event is 36 as well as my sample space also 36. So the 36 by 36, which is equal to 1. So the probability of getting sum less than or equal to 12 is 1, which means 100% happening here. 100% happening here. Why? Because if I take any item from the 36 items, all or their sum is always less than 12, less than or equal to 12. So event is 36, sample space also 36. Then the probability will become 1. The concept of deck of cards. Deck of cards means it's a pack of cards. They are 52 in the number. There are 4 types: heart, diamond, club and spade. These 52 deck of cards have been 4 types. They are heart, diamond, club, spade and 2 colors. Half part is red color, half part is black color. Within them, each part of them has 13 cards. Let's say spade. What is spade? This is the spade. In the spade, we have 10 cards which are named as 1, 2, 3, 4 and so on 10. Up to 10, we have 10 cards in the spade which are named as 1, 2, 3, 4 and so on 10. We have 10 cards of spade which are named as 1, 2, 3, 4 and so on 10. And also we have 3 special cards as J, Q, K. These are 3 special cards. Total 10 plus 3, 13. The card number 1, I can call it as A or S. So in the deck of cards, we have 10 numbered cards and 3 special cards of J, Q, K and 1 ace card. Total 13 cards. In each type, we have 13 cards, 1 ace card, 9 numbered cards, 3 special cards. They are J, Q, K. 13 plus 13 plus 13 plus 13. Total 52 cards we have. Here JQK can call it as a face cards. 3 face cards in spades, and I have 3 face cards in club. I have 3 face cards in diamond. I have 3 face cards in heart also. Total 3 into 4, 12. Total I have 12 face cards in the deck of cards. I have 4 aces. See, in the spade I have 1 ace. In club I have 1 ace. In diamond I have 1 ace. In heart also I have 1 ace. Total I have 4 ace cards, which means in a deck of card I have 52 cards. They are 4 types. They are heart, diamond, club, spade. Each type has 13 cards. Within the 13 I have 1 ace card and 9 numbered cards and 3 special cards. They are JQK. They are called as face cards. Data about the deck of cards you must be remembered while solving the problems on the cards in the concept of probability. Example number 6. Find the following favorable outcome or event from the deck of cards. From the deck of cards, we have to find the favorable outcome or the event. Simply, the favorable outcome means the cards which satisfy our condition. So, what is first event he is asking? A card of spade or ace. A card of spade or ace. How many spade cards we have? We know that we have 13 spades. So, 13 plus ace cards. How many ace cards we have? We have 4 ace cards. But I am considering only 3 ace cards. Why? Because 1 ace card I have already taken in the spades. So, my event will become 13 spades plus 3 ace cards. The total, the event is 16 here. The second event is, the condition is black king. So, in the deck of cards, how many black kings we have? Simply, see, spade is 1 black type, club also 1 black type. In the spade, we have 1 king. K means king, Q means queen, J means jack. So, here asking that how many kings, how many black kings? Here is 1 king, here is 1 king. So, I have 2 black kings. That is the event of 2 black kings. The third event he is asking is neither jack nor king. We have to find the event of neither jack nor the king. See, we know total 52 cards. I am deducting jack and king from the 52 cards. Then I will get neither jack nor the king. Listen carefully. I have total 52 deck of cards. From the 52 deck of cards, I am removing jacks as well as I am removing kings. Then I will get the cards neither jack nor king. So I have total 52 cards minus I have 4 jack cards plus I have 4 kings. I am removing from 52 cards 4 jacks and 4 kings. By removing them, I will get 44 cards. These 44 cards are neither jack nor king. Come to example number 7. What is example number 7 here? If a number chosen randomly from the following numbers. So, the numbers are minus 3, minus 2, minus 1, 0, 1, 2, 3. Here total 7 numbers. A number chosen randomly from these 7 numbers. Then find the probability of that. The square of that number is less than 4. Same here also we have to find the sample space. What is the sample space here? Simply all these 3 outcomes are sample spaces. So my sample space is 7. Sample space is nothing but all the possible outcomes or total possible outcomes is 7. So I have sample space 7. Then I have to find the event. Event means simply which satisfied my condition 4. Here my condition is square of the number is less than 4. I am checking all the favorable outcomes which square is less than 4. For example, I am checking minus 3. What is minus 3? 9. Then come to What is square of minus 2? This is 4. I am checking each one. Why? Because I have to find out the which outcome satisfied my condition. So what is condition here? The square of number is less than 4. I am checking 7 possible numbers here which are less than 4. Let's say the first possibility, 3 square minus 3 square equal to 9. So this is not less than 4. So I won't take this. Then coming to minus 2 square equal to 4. This is also not less than 4. So I am not taking this. Then come to minus square equal to 1. This is less than 4. So I am taking this. 0 square is nothing but 0. Also this is less than 4. So I am taking this. 1 square is equal to 1. This is less than 4. So I am taking this. 2 square equal to 4. So this is not less than 4. So I am not taking this. In this manner, I am checking all the favorable conditions which satisfy my condition. By checking all the 7 possibilities, I got 3 favorable outcomes. That is 1, this is 2, this is 3. So I have 3 favorable outcomes. They are minus 1, 0, 3. I have 3 favorable outcomes which are satisfied my condition. So now I got the sample space or total possible outcomes, as well as I got the favorable outcome or event. Simply I am substituting in the formula of the probability. Simply the probability is event by sample space or the favorable outcome by total possible outcomes. So I got favorable outcome 3 and total possible outcome 7. By substituting, I will get the probability 3 by 7. See the example number 8. Find the probability that in a leap year there will be 53 Tuesdays. We have to find the probability of 53 Tuesdays in a leap year. Listen carefully. We have to find the probability of 53 Tuesdays in a leap year. Okay, that's the problem. We know that. What is leap year? Leap year is which has 366 days. How many weeks are there? Simply to find the weeks in a particular leap year, we have to divide 366 by 7. So I am dividing this 366 by 7. Then I will get 52 weeks and 2 extra remaining days. So a leap year has 52 weeks and 2 extra days. 52 weeks means we have 52 Sundays, we have 52 Mondays, we have 52 Tuesdays, we have 52 Thursdays, we have 52 Sundays, we have 52 Saturdays, we have 52 Fridays, we have 52 Thursdays, we have 52 Wednesdays. Means all the 7 days have 52. Along with them, we have 2 extra days. These 2 extra days can be Sunday, Monday. These 2 extra days can be Monday, Tuesday. These 2 extra days can be Tuesday, Wednesday. These 2 extra days can be Wednesday, Thursday. These 2 extra days can be Thursday, Friday. These 2 extra days can be Friday, Saturday. And these 2 extra days can be Saturday and Sunday. Which means 2 extra days can be any of this. Means these are all the possible outcomes. These are all the possible outcomes. From the given data, I have 7 possible outcomes. 7 possible outcomes means this is nothing but my sample space. Then coming to the favorable outcome. What is the favorable outcome? Simply the favorable outcome is an event which satisfied my condition. See here, we have to find the outcome which satisfied our condition from the given sample space. See how many items included Tuesday. See here, this item. See, this item included Tuesday and this item also included Tuesday except these 2 items in the 7 items, except these 2 items in the 7 items not included Tuesday. So my favorable outcome will be Monday, Tuesday and Tuesday, Wednesday. Why? Because only these 2 items satisfying my condition. So from the definition of events which satisfy my condition, that will become the event. So I am taking these 2 as the events, Monday, Tuesday and Tuesday, Wednesday will become my favorable outcome or events. In the problem, now I got the sample space, which is nothing but total possible outcomes, as well as I got the favorable outcome, which is nothing but event. So my sample space is 7, my favorable outcome is 2. So the probability of getting 53 Tuesdays or the probability of getting 53rd Tuesday will be 2 by 7. So this is all about the probability. So in this manner, we have to solve the concept of probability or problems of probability. If you feel this chapter is very informative, please share to your friends as well as subscribe the channel. In upcoming videos also, you will get more concepts of mathematics as well as the problems which are asked in the competitive exams as well. Suggest your friends also subscribe the channel and follow the channel.